Hello, welcome to Operations Management. In this lecture, I will talk about linear programming formulation. I will use this problem to explain how to formulate a problem using linear programming. The question is, an appliance manufacturer produces two models of microwave ovens, H and W. Both require fabrication and assembly work. Each H uses 4 hours of fabrication and 2 hours of assembly, and each W uses 2 hours of fabrication and 6 hours of assembly. There are 600 fabrication hours available this week and 480 hours of assembly. Each H contributes to $40 to profits, and each W contributes $30 to profits. What quantities of H and W will maximize profit? So we discussed in linear programming formulation, the first step is to define our decision variables. So what are we trying to determine? So if you see here in question, it says what quantities of H and W will maximize our profit. So that's the decision we are making. So I will define XH as the number of units of H microwaves produced. And then XW is number of units of W microwaves produced. So this is the first step. These are our decisions which we are trying to make. So the next step would be to define our objective function. So we discussed objective function can be profit or cost. So in this case they talk about profit, so our objective function will be profit. So it will be, we are trying to maximize our profit. So we have to write the function for this. So if you see, they say each H contributes to $40 to profits. So if each one of them contributes $40, if I produce one unit, I will make $40 profit. If I produce two units, that's 40 multiplied by 2, I will make $80 profit. If I produce 3 units, I will make 40 multiplied by 3, $120 of profit, so on. So here I am saying we are producing XH quantity, so 40 times XH would be our profit we will be making. So we don't know XH, that is what we are trying to determine at this, we will try to determine. So our profit from H microwaves would be 40 times XH plus the other, and each W contributes to 30 profit. So if we have, again the same concept, if we have if we produce 1 W, we will make $30 profit. If we produce 2 W microwaves, we will make 60, and then so on. So if we make XW, we will make a profit of 30 times XW. So that will be our profit function. So we are trying to maximize this function. So that's our objective function. So the next thing is we said we have to define our constraints. So to define our constraints, our question says, so this is limitations to our resources available. Our question says there are 600 fabrication hours available and 480 hours of assembly available. So that is what we have. So if you see, I will try to draw a table here now. Suppose if we have H and we have W, and I represent fabrication here, fabrication, and then we have assembly. So if you see, the question says both require fabrication and assembly work. Each H uses 4 hours of fabrication. That means H is going to use 4 hours of fabrication and 2 hours of assemblies. So that is 2 hours. And then each W uses 2 hours of fabrication. So this is 2 hours and 6 hours of assembly. And overall, if you see, the total is we have 600 fabrication hours. So that's 600, and then assembly is we have 480 hours. So if you see, I am producing XH of H microwaves and XW of W microwaves. So if you see the fabrication for each H produced, it will use 4 hours. So 4 times 1, if I produce 1 H microwave, it will take 4 hours. If I produce 2, it will take 8. So on, if I produce XH, that's the amount of time. It's 4 times XH is the amount of time fabrication will take. So I will write constraints here. So this is fabrication constraint. So for to produce XH of H microwaves, it will take 4xh amount of time in fabrication. Similarly, to produce W, it takes the same concept, 2 hours for 1 W to be produced. Then 2 times 2, 4 hours for 2 W to be produced, and 2xW is the amount of time to taken to produce XW amount of W microwaves. So this will be 2xW. So this is the total fabrication time that it will take to produce both H and W. So this should be less than 600, as we have only 600 hours available. Similarly, if you take assembly this way, 2 hours it will take to assemble 1 unit of H microwave. So 2 times we are producing XH of H microwaves. So that's the time taken. And then the time taken to produce XW of W microwaves is 6 times XW. So this should be less than 480 hours. So this is fabrication constraint, and this is assembly constraint. And then finally we will have non-negativity constraints. So we cannot produce negative microwaves, so the amount of xh, the number of h microwaves should be greater than or equal to 0. So we can produce 0 microwaves, so that means we are not producing any h microwaves. So similarly the other constraint would be xw greater than or equal to 0. So if you see, this is a linear programming because all the equations which we wrote here has a power of 1. So if you see this has power 1, power 1, power 1, power 1, this has power 1, power 1, power 1, and power 1. So that's how you will do the linear programming formulation. So this concludes my lecture on linear programming formulation. Thank you.